All right, let's start with the walkthrough, the actual exercises. Again, you want to do the exercises with me, you need access to the no-name platform. To gain access to the no-name platform, you need to send an email to training@nonamesecurity.com identifying the course you need resources for. Okay, within a few hours, I'll provide the resources to you. Okay. All right, so what are we going to do in this exercise? Well, we're going to explore and debug some findings and some incidents. That's what we're going to do, right? Um, we're going to log in. We're going to talk about a posture environment finding, a posture application finding. We're going to talk a little bit about how you can go about managing attackers, okay? And then we're going to debug an Ebola, a broken object level authorization, and a command injection, okay? And again, what I want you to take with this is the span of understanding that you have to have in order to be able to debug just for uh, security vulnerabilities, right? And these four security vulnerabilities, they have been identified in our customer environments. I just took them and I recreated them using my own sets of data, my own APIs. Okay, just a quick heads up. All right, so the very first thing we're going to do is we're going to log into the no-name platform. I'm already in it. I'm just going to log out and I'm going to relog. The username or the email is admin@acme.com, and the password, I'll put the password right after so you get to see it. Capital N, no name, one, exclamation. Capital N, no name, one, exclamation. That's your password. Okay, so let me go type the password. Exclamation, log in. Cool. The other thing I want to mention, the version we're using is 3.28.20. This is the latest long-term support LTS version. Okay, and of course the material, the courseware follows the long-term support. And I want you to go under findings and I want you to find one of the internet-facing host support weak TLS cipher suites. There are two. I want you to use the first one, the one that has the long host name, the one that starts with GK 2022 and so on. Okay. The reason why I want you to use this one as opposed to the Acme Airline is because this one has more APIs, so you're going to see more things being populated. Okay. All right. So let's select it. Let's look at the details. Right. So the details say that an internet-facing host serving 10 APIs allows 10 weak TLS cipher suites. It's pretty sweet, right? A lot of details. The issuer, Amazon RSA, start date, expiration date, and so on. Okay, so that's a certificate. Okay. Oh, what the heck is a cipher suite, right? Maybe some of us may not be aware of what a cipher suite is. So let me go to the Wikipedia page. Here it is. A cipher suite is a set of algorithms that help secure a network connection. Cipher suites are used in the TLS, transport layer security, or SSL, secure circuit layer. Okay. The algorithms include key exchange algorithm, massive, right? How to best securely exchange your keys so you can establish your secure communication, your bulk encryption, and the message authentication code. That's important stuff right here. Okay. Right. I don't need this yet. Let's go back to the no-name platform. To the bottom, I will see all the different APIs that are affected, that are being served by that host. Okay. I will see all that. And why that's a problem, cipher suites defined as insecure or weak by IANA. IANA pretty much is the, don't remember what IANA stands for. Yeah, let's Google it. There, Internet Assigned Numbers Authority. Okay, pretty much provide us with standards and so on, right? About accessing the internet, etc. And it's of course the U.S. government. Okay. Okay, so you shouldn't be used weak or insecure. That's what it says. Okay. Now, if you want to see which weak and insecure TLS cipher suites, the 10 weak TLS cipher suites that are used, that are defined in that certificate, in that TLS, you got to go to the protocol, the evidence, right? So if I go to the evidence, I'm going to get a list of all of these. Okay. And if I click it, that's why when I said earlier on, these are indisputable evidence. So if I click any one of these, it's going to take me under the cipher suite.info site, which is pretty much headquarters for everything related to cipher suites. And I will see that the corresponding cipher suite is weak. And some of us may have no clue what that means, right? So that's why you have the FAQ. And you can say, okay, what do we mean by insecure? What do we mean by weak, secure, or recommended, right? And you can go and read it. In all honesty, secure and recommended is what you should be using, okay? Insecure, forget it. They're very weak. It doesn't take a lot of effort to be broken. Weak, on the other hand, they're dated. Only use them for older OSs and so on, okay? Older technologies. Secure and recommended is what you should be using. And that's what this means. Now, the other thing I want to mention, I already mentioned it in passing. False positive doesn't apply in this particular case. You cannot resolve something. The only thing you can do is resolve not verified. You know it has been fixed. The no-name platform has yet to detect it, right? You can come in here and mark it resolved or not verified. Okay, so it doesn't bother you anymore. It's not visible in your area. When the no-name platform, again, you get the warnings. Once the no-name platform confirms, scans again, and identifies that the cipher suites have been updated, then it's going to go ahead and mark the corresponding finding from resolved not verified to resolved. So it's out of your control. Resolved is out of your control, the user's control. Okay. Okie dokie. All right. So that's with respect to the very first posture environment finding, right? That's what we completed. And of course, the section of this exercise is done.